Okay, students. Today I'm going to touch on chapter 2.4, which is actually on velocity changes. So in this section 2.4, the learning outcomes is this. Okay, please take note. Okay, in this section, you need to state what is meant by uniform acceleration, and then you need to calculate value of acceleration using the formula given, change in velocity, as well as time taken. So actually in my last lessons, I've actually covered this with you. Acceleration is actually the rate of change of velocity. Now, if you remember, this was the formula that I covered with you. Okay, guys, for the entire of this chapter 2, right, this is the most important formula that you need to do, because need to know. Once you know this, you will then be able to use the formula to solve quite a number of questions. But of course, the interpretation of the graph is also important. So the formula, if you summarize it, is actually A equals to V minus U divided by T. Now, in this context, A is the acceleration, V is final velocity, U is initial velocity, and all these are actually in meter per second. Now, acceleration is meter per second square. Take note of it. And time, the SI unit is second. So when you have meter per second divide by second, what you have is meter per second square. So let me write this carefully. Meter per second square. So make sure that when you calculate, the units tally. So there are a few things that you might want to take note. First is this: when the velocity of a moving object is constant, that means there's no change, right? That means initially U is V and V is V, right? If you substitute the value of A, right, A will then be V minus V divided by T. It will be equals to 0. Now, in other words, this actually obeys Newton's first law. If your velocity is constant, you will have no acceleration. But no acceleration doesn't mean that it's stationary. It only means that your velocity is constant. So this is note number 1. Now, note number 2. If you have a velocity of a moving object and it's increasing. Now remember, ping pong ball, when it is dropped from the top, right? Your velocity keeps increasing. So what you have is an acceleration whereby A is greater than 0. So this is something you need to take note of. Okay, next important note: if you have a velocity of object that's decreasing, remember the case whereby we throw the ping pong ball up, you find that as it goes up, the velocity upwards starts to decrease. Then you find that it is decelerating or retarding. Okay, now retarding implies that acceleration is less than 0. In other words, is decelerating or is retarding. Now the noun for it is deceleration or retardation. Okay, this is actually covered in your text, so you might want to read a bit carefully when you refer to your textbook. So now, I've actually summarized this point, which will be very useful when it comes to problem solving. Now, the problem solving is this: whenever you encounter a question, first and foremost, you have to collect and summarize the data. Look for keywords. Okay. Now, when they mention start, that means you're talking about the beginning. Now, this is important in the graphical sense. I will illustrate later in the later sections. Now, if you say from rest, it means U is equal to 0. Now, if let's say an object comes to a stop, it means your final velocity V is equal to 0. So these are some of the keywords you need to look for. Then also, you need to understand the requirements of question. Are they asking you to find acceleration or final velocity or initial velocity. Now, once you know that, right, then you will need to be able to manipulate this formula using algebra to actually manipulate carefully. So if you are to find acceleration, you have a equals to v minus u over t. If you need to find v, right, say for example v, so what you do is you bring t towards the left, right? So you have at equals to v minus u. So from a denominator, it goes t as a denominator on the right hand side, it goes to left hand side, becomes at. So if you want to find the value of v, right, okay, so v will therefore be on the right hand side. It will then, what you do is you take the minus u on the right hand side, put the left hand side. If something is negative on the right hand side, when you put the left hand side, it becomes positive. Okay, plus u plus at, and this will be equals to v. Okay, so if you rearrange what you have by manipulating is v equals to u plus at. Now you don't need to memorize this. You ought to learn how to so-called derive by using algebra. So do take note of this, okay? Can? So you will need to then make use of and apply the relevant equations. And finally, when you calculate, check for answer for correct units and reasonable value of quantity. Okay, so as a case in point, I showed to you this example. I think this example will help you a lot. So please look at this example. Now, for work example 2.5, they ask you to calculate acceleration of the car. Now, in this context, you know that you need to calculate A. And A is governed by this formula. A is equals to V minus U divided by T. So in the first situation, you have a car speeding up from rest to a velocity of 12 meters per second in 4 seconds. So based on that, right, so if you see the word from rest, right, it means that U is equals to, yes, U is equals to 0. Then it goes to a velocity of 12 meters per second. Now, if they say from and to, right, from U equals to 0, it becomes 12 meters per second. So that means this is actually V. Okay? And 4 seconds, as you know, is T. Now, armed with this knowledge, right, you can then substitute A equals to V minus U divided by T nicely, right? So V is 12 plus 12, right? Always remember, if they never mention negative, you just have to put a positive there. Then U is 0 meter per second. You can, of course, put a plus, right? But it doesn't matter. So when you substitute A equals to V minus U, so V is 12 minus U is 0, T is 4 seconds. So what you have is 12 minus 0 is 12. 12 divided by 4 is 3 meter per second square. Now notice that you have to, if you really want your working to be always accurate, it is always good to write down the units. But if you don't wish to write down the units, it's still alright, but your final answer, you must have the units. Okay, so if you don't have the units, even if you give the correct answer, you will not get the full marks. Now when you calculate, right, what you have is this value, which is positive 3 meter per second square. Now if it's positive, A is greater than 0. And actually, there's one thing I need to mention to you. A is greater than 0. In other words, it is accelerating, okay, in a positive sense. So in other words, right, if your car is traveling in this direction, okay, we call this positive direction, right? Okay, positive I use short form, right? So if your value is positive 3.0 meter per second square, that means to say, right, it means to say that you are actually accelerating in the positive direction. So in other words, it is speeding up the positive direction. Okay, I got to make this clear to you, right? If you're not sure, you can play this video over and over again until you understand. Okay, part 2 or part B. Okay, since it's speeding up, right? Part A, it just, okay, A is greater than 0. Now, for B, right, when you see the word slowing down, right, chances are you will come to a conclusion that the acceleration is negative. Okay, let's check. Okay, so it slows down from a velocity. When you see the word from 12 meter per second, what this means is that this is u, okay, from and then to 2 meter per second, right? Chances are this is v, and t is 5 seconds. So what we have, right, it slows down from 12 meter per second to 2 meter per second in 5 seconds, right? Now let's look at part B, look at the working. Okay, v is 2 meter per second, u is 12, and both are positive because the question never indicates them as negative, so I put it as positive. So substituting it to a formula, a equals to v minus u divided by t, we have 2 meter per second minus positive 12 is still minus. Okay, 2 minus 12 is minus 10. Minus 10 divided by 5 is minus 2.0 meter per second. Okay, always remember you must write your units. Okay, some students are careless here. You have your answer minus 2.0, but you never mention units. Now, you don't mention units, I don't know what you're talking about, and marks will be deducted. So in this sense, right, now, if you are talking about positive direction is the direction of the car, right? And then you have a negative, right? A is less than 0. What it means is that it is slowing down in the positive direction. So this is the second situation. Okay, now third situation, you see the word speeding up. Now speeding up the thing that first comes to mind is that A is greater than 0. But as I will illustrate to you later on, it's not so simple, right? So it's speeding up. Technically, you tell yourself is accelerating. Now, from rest, okay, you see the word from rest, right? What this means is that, okay, u is from. When you see the word rest, right, use u is equals to 0. Then after that, okay, minus 8 meter per second, right, is v, the value of v. And this, of course, is t. So what you do is you substitute this, right, into the formula religiously. Then you find that for part C, right, A equals, no, you see here, v is minus 8, okay, negative, right, and u is 0 because it starts from rest. So what you have to do is you substitute the value v minus u, right? V minus u is minus 8 minus 0. It is still minus 8. Now minus 8 divided by 4 seconds, you get minus 2 meter per second square. Okay, so now when you have minus 2 meter per second square, you might first come to a conclusion that it is actually slowing down or decelerating. But remember, part C, it says it is speeding up. Now, was there an error in the question, you may ask? Actually, there's no error. look very carefully, right? Because when you first start, your velocity is -8. Now, if you remember, right, velocity is a vector unit. It's a vector quantity. So if you have something plus 2 meter per second, is to the right hand side, positive. We call this positive direction. Now if it's minus 8 meter per second, it's actually you're going 8 meters per second in a negative direction. So it's not wrong, right? But actually when you see it negative, it only means that it is speeding out a equals to 0 in the negative direction. So in other words, right, the car is actually speeding up towards the negative direction, which is like this. Okay, so in other words, it is picking up, but in a positive sense, right, when you refer to something like a graph, right, you will find that it seems to be slowing down because the value is negative. So don't draw the wrong conclusion, okay? Because sometimes they may require you to interpret what you see based on what you calculate. Now, part D. Now, it says it's slowing down, right? First thing first, you might think that A is less than 0. But once again, this example is to show you that it may be otherwise. So it slows down from a velocity of -8. So when you see from, right, you're talking about U is equals to -8, right? To a velocity of -4. Okay, this is V in 8 seconds T. So you have all these things, you substitute, right? V is equals to -4. U is -8. Because initially it goes from -8 meter per second to -4. That means to say a vehicle is going at a speed of 8 meter per second in the negative direction. Then it starts to slow down to -4 meter per second. So the sign is important, right? Okay, now this you got to be very careful, right? Because when you substitute A equals to V minus U over T, right, your U is a negative. Now if you have negative and negative, it becomes positive. So you must be careful. Okay, don't make careless mistake. Because you make careless mistake, you get the wrong answer. So minus A equals to V minus U divided by T. V is -4. Minus 8 is actually plus 8 minus 4. What you get is 4. 4 divided by 8 is 0.5 meter per second. So when you see something positive, you're likely to think that it is accelerating. But this is not true, because what happened is that the car is going in the negative direction. So when you see positive, right, it only means that it is slowing down in the negative direction. Okay, so this will kind of sum up section 2.4. I hope you understand. If you don't understand, what I suggest is you will play the video over and over again until you catch what Mr. C is trying to tell you. So with that, I come to the end of section 2.4.